Today we'll start chapter 4 and we'll review basic graphs. Start by graphing the sine function. And let's begin with making a table of values. And just to make it easier, let's use the pi over 4, multiples of pi over 4. Pi over 4 times 1 is pi over 4 for the x. Pi over 4 times 2 is pi over 2, and so on. So we'll use these values of x. And if you want to look at the table of values, the table of values will, or maybe you memorized it, will tell us the values of y. For example, for pi over 4, remember y coordinate is your sine x is your y coordinate, so sine of 0 is 0. X coordinate, y coordinate is 0. Sine of pi over 4, y coordinate is square root of 2 over 2. I'm going to simplify square root of 2 over 2 and write it as a decimal to make it easier to calculate. Is 0.7. Pi x is pi over 2, y is 1. When x is 3 pi over 4, I'm looking at the table. When x is 3 pi over 4, then the y coordinate is also square root of 2 over 2, which is as well 0.7, 0, negative 0.7, negative 1, negative 0.7, and sine of 2 pi, 360 degrees, we go back to 0, it is 0. Now, let me make the graph, the sketch of a graph, very rough. I have more precise drawing. I'm going to show you later. So here's my x and here's the y. In this case, y represents the sine of x. And we start by graphing these points. This is point 0, 0, pi over 4. Let's make the equal increment of pi over 4, pi, another 2 pi over 4, which is pi over 2, 3 pi over 4, so it's pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then the 2 pi. So we're gonna make points. We're gonna put the points on the graph. 0, 0, pi over 4, 0, 7. So if this is my 1, the 0.7 will be somewhere right here. Oops. And then pi over 2, 1. Here's my 1. And then 3 pi over 4, y is equal 0.7 again. And then pi, y equals 0. 5 pi over 4 represents, here's my negative 1. Negative 0.7 will be somewhere right here. And then pi, 5 pi over 4, negative 0.7. 3 pi over 2 is negative 1. 7 pi over 4 is negative 0.7. 2 pi is 0. So now we're going to connect these points with a nice wavy line. And here is our graph of a sine function. Now let's move to the nicer version of the graph. Here are the points that we found, and we plotted on a graph, and then we connected the graph. We can also graph this same function y equals sine over x using the unit circle. Let's look at this unit circle. So from the definition 3 circular functions, we know that if the point x, y is any point on the unit circle, and t is the distance from 1, 0 to that point x, y along the circumference of the circle, then x is equal cosine t, y is equal sine t, tangent t is equal y over x, and so on. So as we move the point xy along the circumference, and t is increasing from 0 to pi over 2, meaning that point P with the coordinates xy travels from 1, 0 to 0, 1, then y equals sine t increases from 0 to 1. Remember, this is your y coordinate. And as we go to the second quarter, y starts decreasing. Go to the third quarter, it starts increasing to the negative values, increase to -1, and then again decreasing back to 0. Let's look at the graph. We can better visualize it if we see the unit circle and the graph next to each other. So as we move along the circumference, t is increasing from 0.10 to 0.01, pi over 4, t sine t, which is y, is equal 0.7 or square root of 2 over 2, and then we go over pi over 2 right here will give us the y coordinate equals 1, and then we move to the x coordinate of 3 pi over 4, and it starts decreasing, and then as we go to pi, as we move along the circumference to pi, then again our y coordinates started increasing to the negative values, increase to the -1 at the point of x equals 3 pi over 2, and go back to 0. Let's now extend the sine graph. So here's our graph from 0 to 2 pi. We want to extend it, and we notice that it goes increasing every pi over 2, decreasing pi over 2, increasing to the negative values on the segment from pi to 3 pi over 2, and then decreasing to 0. So it kind of has a wavy shape. We'll continue this shape. We can continue this shape. Notice that as we pass 2 pi, we'll begin name angles that are coterminal with the angles from 0 to 2 pi. So we'll repeat the graph again. Go up to 1, and then go down to 0, down to -1, up to 0, and so on. And the same way we can graph the left side as well, from -2 pi to 0. This brings us to the following definitions. So the first definition is the period. For any function y equals f of x, the smallest positive number of p for which f of x plus p equals f of x, for all x in the domain of f is called the period of f of x. And we notice that the graph of the sine never goes above 1 and below -1. Now the next definition is amplitude. If the greatest value of y is m and the least value of y is m, then the amplitude of the graph of y is defined to be 1/2 capital M minus m absolute value. So in the case of the amplitude for y equals sine x, the greatest value y goes is 1. The smallest value, remember the graph, it goes to 1 and -1. So the largest value is 1. The smallest value is -1. We're talking about y. And we get, this is 2. 1/2 times 2 is 1. So the amplitude of the sine graph is 1. And this definition of 0. A zero-for function is any domain value x equals c for which f of c equals 0. So what were the zeros of the sine function? It was 0, pi, 2 pi. Now let's talk about domain. We know that domain for any function is the y values. Now we also know that our function y equals sine x did not go above 1 and did not go below -1. Therefore, here is the domain of our function from -1 to 1. Now I want you to do the exercise and graph the cosine function.